All right, so this starts unit 1. So unit 0 is called like the prerequisite unit. And so unit 1 kind of starts more of what the pre-calculus stuff is. But a lot of this stuff you'll recognize from Algebra 2 also. So slide 1, they wanted you just to like draw a graph and notice or wonder something. Did you guys notice or wonder anything when you drew the graph? What determines the speed the turtle moved?
X-axis, like how, well, however you put it, the best way to go.
Right. So the steepness of the steepness of the line or curve or whatever determines the speed. What determined the direction the turtle moved? That was like if there was a positive slope or a negative slope, it determined the direction. Okay. And then slide 2 wants you to finish the story. So I'll just read what I wrote and then you guys can just check yours. So it starts off, for the first 2 seconds, the turtle moved away from the water at a constant rate. And then the turtle did not move at all for 2 seconds. So then that distance wasn't changing. The turtle wasn't moving for 2 seconds. All right, then the turtle moved away at a constant rate and then stayed still again for 3 seconds. All right, and then slide 4. Let me pull it up. All right, this is slide 4. And the first question is, how far away from the water was the turtle at 8 seconds? What did you guys say? 10 feet. So we go 8 seconds, go over, and that's going to be 10 feet right there. All right, and then question 2 says, at what time was the turtle 4 feet away? Yeah, so here's the 4 feet, and that is going to correlate with 5 seconds. And then question 3 says, at what time was the turtle 12 feet away? Never. Never got 12 feet away. Good job. Okay. And then we have this weird graph. Can that be a graph that shows the distance the turtle is away? Why not?
It's not linear.
It doesn't have to be linear. That's okay though.
The turtle can't split in half.
Yeah, when you watched it, the turtle split in half, and that can't happen. So a turtle can't, like at however many, like at 5 seconds, it can't be here and here. So you can say something like the turtle can't be at 2 places at once, and when you play the thing, you can see that. All right, and then slide 10. Okay, so question 1, what is the turtle's distance at 3 seconds? What do you guys think? Yep, that's going to be 6. Cool. And then when is the turtle 4 feet away?
2, 5, 7.
Good job. 2, 5, and 7 seconds. Alright, so even though it might not seem like it, we actually covered a lot of concepts about functions with this turtle activity. So we learned how to evaluate a function. We learned like kind of when a function doesn't, or something is not a function. Alright, so a function is a relationship between 2 variables where one variable determines the other. Alright, you guys can go ahead and close your Chromebooks and take things out of your ears. Okay, so we're going to write that f of x equals y. And so we said a function is where one variable determines the other. So if we're talking about x and y, which one of those determines the other? Does does X determine Y or does Y determine X? X determines Y. So X is what is called the independent variable. Or it's also called the input. So X is what goes into the function, Y is what comes out of the function. So Y is the dependent variable. Or the output. Struggling writing. There. I left out an N. Alright, and then F is just the name of the function. So a function can be named F, H, G, can be anything really. Later we're going to have a function called P for people, I guess. So that's just the name. Alright, so there are a ton of relations that are not functions. So a function is a special type of relationship. So for a function, each input can have only one output. So when you get a situation like that turtle with the turtle splits, that's not a function. So that was a time when a turtle was trying to be two places at one time. So two outputs for one input. One input with two outputs, I should say. Alright, and then another thing we're going to do today is evaluate functions. So to evaluate a function, plug the value in for x. Now it technically doesn't have to be a value, and we'll get to that when we get to example 2. So you can plug in a different variable. We're going to plug in a smiley face. So it's just you put something in for x to get the output. Alright, so on example 1, we're going to look at these relations. Sometimes they're words, sometimes they're ordered pairs, sometimes they're a graph. And we're going to determine if it represents a function. Alright, so A is just some ordered pairs. Would you say that's a function? No. What's the problem?
0 has 2 outputs.
Yeah. 0 is paired with -2 and 0 is paired with 7, so that can't happen. So 0 has 2 outputs. Alright, and then for B, X is the height of a student, so like that's the input, the height of the student, and then Y is his or her age. Do you think this is a function? Is there only one age for every height? So we did this last class. Like I'm 5'8", I'm not a student, but I'm 5'8", and there were other people who were 5'8" that were different ages than I am. So we're gonna say no. Height can be paired with multiple ages. Right, and then for C, X is the number of minutes that you run on a treadmill, and Y is the number of calories that you burn. What do you think? Is that a function? Should be. Alright, what about D? Do you remember what you used to tell if a graph is a function? vertical line test. So a lot of people might last I said pencil test. Is that how y'all remember it, the pencil test? Okay, so apparently Miss Stewart called it the pencil test, is what they told me. So it's the vertical line test. If a vertical line crosses more than one place anywhere on the graph, it is not a function. So we're going to say no. And the reason we're going to say fails the vertical line test. So just in that one example, and there's many examples, it's one example for, it looks like it's paired with 2 and -2, so that can't happen. Alright, and then for number 2, we're going to evaluate this function. So this function is called g. Everything that we put into g, we're going to square, and then we're going to add 5 to. So this is g of 2, so that means we're going to take 2, we're going to put it in for x, we're going to square it, and then we're going to add 5 to it. So what do you get when you square 2? And then we add 5 to it, so that's going to be 9. Then we're going to put in -7, so that means we're going to square -7, what are we going to get?
49.
And then we're going to add 5 to it, and we're going to get 54. Alright, the next ones are kind of weird. So whenever I do g of t, that just means I'm going to take t, I'm going to square it, and then I'm going to add 5 to it, and we're done. You don't have to do anything else. Alright, for d, what are we going to put in? A smiley face. So we're going to square a smiley face, and then we're going to add 5 to it. Right, and then the last one, we're putting in x plus h. So we're going to square it, and then add 5 to it. So that might be kind of weird. Probably in Algebra 2, you only put in numbers, but you can put in other variables into function. Okay, and then number 3, we are going to let P of t represent the people in the store, the number of people in the store, t hours after the store opens at 8 a.m. We're going to interpret the meaning of each of the following statements in context. And so we have P of 2 equals 83. So one of those things is hours since the store opened, and the other thing is people in the store. So what is 2? 2 hours after opening. There are 83 people in the store. Alright, B is kind of weird. So on B we have that P of 3 is equal to P of 6. So what do you think that means in the context of the problem?
Yeah, there's open, there is the same amount of people as there is as there many people 6 hours after open.
Exactly. So 3 and 6 hours after opening. There are the same number of people. Alright, and then C is a lot like A, except we don't actually have a number, we have a variable, but that's fine. So where this said 2 hours after opening, this one is just going to say L hours after opening.